Let's talk about quadratic functions. As we work through this, we're going to be doing a lot of comparing. How do you determine, is it linear or is it quadratic? So it's important that we refresh on our linearity lessons. You should be pretty familiar with them. We've been working with them all year long. And now we're going to start getting real familiar with quadratics. So the first thing I want to talk about is just the standard form. We know that the standard form for a linear function is ax plus by equals c. And quite often we'll manipulate that function into slope-intercept form, which is y equals mx plus b. But the actual standard form is ax plus by equals c. Whereas with the quadratic, the standard form is ax squared plus bx plus c. Very important to note, the biggest difference, the way that you're going to determine is an equation quadratic or linear, is the largest exponent. A quadratic function has the largest exponent of 2, whereas linear, this would just be raised to the first power. So if it is squared, it is quadratic. So an example would be, we could do it in slope-intercept form. Let's say we had y equals 2x minus 3. We see that x is raised to the first power, so that would be linear. For quadratic, let's say we had something like y equals 2x squared minus 3x plus 1. That would be written in standard form. We can see the exponent is 2 on the highest exponent is a 2, therefore that would be quadratic. Okay? Parent function, real quick. Linear parent function is y equals x, and we know that to be this graph that crosses straight through the origin. Slope of 1, y-intercept of 0, just the most basic function in the family. And for quadratics, y equals x squared, again, the most basic function in the family. It's just going to be a parabola that opens upward that does touch the origin. Okay, and then the graphs, for linear, any kind of straight line. So we could have with a positive slope, we could have with a negative slope, we could have a horizontal line, we could have a vertical line, so lots of options. Anytime that it is straight, linear means straight. Anytime it's a straight line, it is linear. Quadratics are always going to give us a parabola. The parabolas can open up or they can open downward, but you will always get a parabola. We'll talk a little bit more about this later, but there's a real easy way to determine if your quadratic is going to open upwards like this one or open downward like this one, and that is the leading coefficient. So remember that when we worked with polynomials, when we were putting them in standard form, we always did the largest exponent down to the smallest exponent, sort of like here, x squared, then x to the first, and then no variable. The leading coefficient, which is going to be the number in front of the variable with the highest power, is going to tell you if the parabola is going to open upward or downward. If the leading coefficient is positive, the parabola will open upward. If the leading coefficient is negative, the parabola will open downward. So just by looking at equations, you can know things about what their graph look like if you know a few little keys like that. Okay? Real quick, let's talk about how to determine if things are quadratic. If you're given a table, we're going to look at a constant, you're going to have constant x values, and then we're going to look for a constant second difference. And we'll talk more about this in a minute. I'll show you an example. But with linearity, we did change in y over change in x, and as long as it was constant the whole way, it was linear. With quadratics, same kind of process, except for it's going to now be the second difference. Okay? With an equation, we talked linear is only going to have an x, whereas quadratic is going to have an x squared. And if you're looking at a graph, if you want to know if it's a quadratic, it's got to be a parabola, right? All right, so let's talk about tables first. How do we tell that tables are quadratics? Well, the first thing we're going to look at is are the x values increasing at a constant rate? So when I go from -4 to -2, is that the same difference from -2 to 0 and from 0 to 2 and 2 to 4? And the answer is yes. All of those are increasing by 2, going up by 2. So now I look at the y column. If I take the difference, so I'm going to do 2 minus 8, I get -6. 0 minus 2, I get -2. 2 minus 0, I get +2. And 8 minus 2, I get +6. You can see those are not the same. So we know this is not linear. What we want to look at are the second differences. That list would have been the first difference. Oops, yeah. Are the second. So now if I do -2 minus -6, be careful with the signs there, that's going to give me a +4. And if I do 2 minus -2, that's going to give me a +4. And if I do 6 minus 2, that's going to give me a +4. So I can see that my second differences are constant. First differences are how we determine linearity. If those were constant, this would be linear. They are not. Second difference are constant. Therefore, this table is quadratic. It is a quadratic table, quadratic data, because the second differences are constant. Okay? Let's look at the second example real quick. 0, 2, 4, 6, 8, 10. I can see the x values are going at a constant rate. That's the first thing I check. And now I'm going to do these differences. I'm going to do -1 minus -2. That's a +1. And I'm going to keep doing that. I'm going to check every one. 0 minus -1, +1. 1 minus 0, 2 minus 1, and 3 and 2. This is first differences that are constant. So this is not quadratic. It said identify if they are quadratic. This is not quadratic. It is linear. Okay? So real simple, when you have a table, if the second differences are constant, that's going to give you a quadratic set of data. Remember that the x values have to be constant as well. Okay? Let's determine if these equations are quadratic or not. Okay, so I have 3x squared minus 4x plus 8. And I'm determining if they are quadratic. The main thing that I look for here, let's get a different color, is my x squared. Because I have the x squared, this is quadratic. When the highest exponent is a 2, then we know we have a quadratic. Here, I don't. My highest exponent is a 1. So this is not a quadratic. It is linear. And that's because of just x, not x squared. Okay? All right, let's talk about how to find other things on our quadratics. This is going to get real calculator heavy. Okay? So we're going to get real comfortable with our calculators, and we're going to be using them a whole bunch. Some of you, that's probably comforting, I hope. So I'll just use this example that's right here since it's still on the screen. We're going to type it in, and we're going to look at some different things and how we would find things on our quadratic. So I'm going to go into my calculator, into my y equals, and I'm going to type in 3. Remember, we use this x next to alpha. We should be real comfortable with that. Here's a squared for you. So you can just push that to square it, or you can do the caret. But if you do that, it just comes straight back down for you. 3x squared minus 4x plus 8. If I graph that, I can see my parabola. It's way up here. Okay? But the calculator will do other things for me to jump right to answers that I want to know. So let's look at what happens when we hit second trace, which is calc. There's some options in there. I see 0, which should look familiar from yesterday's vocab lesson. A 0 of a quadratic function is the x-intercept. A 0 of any function is its x-intercept. So with quadratics, we call them zeros, we call them x-intercepts, we call them roots, we call them solutions. If they ask you for the solution to a quadratic, it's the 0. So if I hit number 2, I know that I'm looking for x-intercepts. And what do I see on my x-axis? There's nothing, right? So the calculator is not going to be able to find any x-intercepts. It's going to tell me there's an error here. There's no x-intercepts, okay? If I look at an equation, let's just change this to a -8 and graph it. Change it to a -8. Now my graph comes all the way down. Now let's try second trace, and let's look for the zeros. If I hit enter, the first question it asks me is for the left bound. Now you have to know what you're looking for. I'm looking for this spot right here where the graph crosses the x-axis. And left bound means tell me a point that's on the left side of the point you're looking for. So if I'm looking for this point, I move my cursor somewhere over left of that point and hit enter. Then it's going to ask me for the right bound. Okay, I'm at this point right here. So as long as my cursor's over here somewhere, I'm to the right of that point. So I'm going to hit enter. I hit enter one more time, and it tells me that the 0, the x-intercept, is at -1.09716. We know that y is always 0 at the x-intercept. So I can use second trace to find my x-intercepts. Let's say I wanted to know this one. Okay, I'm going to come over. It's asking me for the left bound. So I just need to be to the left of the point. The point is here. My cursor's to the left. So I hit enter. Move over to the right. Hit enter. Notice these two little arrows are saying, okay, you're wanting the point that's in between these arrows, right there. Hit enter again, and I can see at 2.43 is my other 0. I'm going to go back to second trace. Zeros obviously is going to be super helpful for you, okay? I also see minimum maximum. This is going to be a great tool as well. If I go down, I know that this graph has a minimum because I was just looking at it and it opened upward, which means it's going to have a lowest point. I'm going to find the minimum. And it's going to be that same process. So the minimum is here, right in the middle. My left bound, the cursor is going to have to be on the left side of this point right here. I move the cursor over here and I hit enter. Now it's asking me for the right bound. I need to move over so that I am on the right side of this point that I'm looking for, and I hit enter. Hit enter again, and I can see the minimum is at 2/3 and -9 1/3. So that is the point that's at the minimum. Now something real important about the minimum. It is a great point for us to know, because the x value of the minimum, this 0.6666 here, that's my axis of symmetry. If I draw a dotted line that goes straight through where x is 2/3, I have my axis of symmetry. X equals 2/3 is my axis of symmetry. It's a vertical line that cuts it in half. My y value, my -9 1/3, is my minimum or my maximum. In this case, my minimum. That is the lowest y value on this entire graph. And then if I write it as a point, as 2/3, -9 1/3, I have my vertex. So this one function on your calculator, second trace minimum, is going to find you your vertex, your minimum, and your axis of symmetry. So get real comfortable, real familiar with these calculators, okay? Okay, we discussed earlier the leading coefficient a little bit. So if I look at this, it says sketch a graph of f of x equals 2x squared minus x minus 6. And it says I'm wanting to sketch a graph. So before I get started, I just kind of want to visualize, like, well, what am I going for here? If I look at the leading coefficient, if it is positive, I know that my graph is going to open upward. That's just kind of one little double check for yourself. Okay? So let's use our calculators. 2x squared minus x minus 6. I'm going to graph that. Now, I'm not going to just go onto my graph and go, okay, it looks like that, done. I'm going to find some specific points. You need to know the x-intercepts, you need to know the y-intercepts, and you need to know the vertex when you're going to sketch a parabola. Okay? So let's find them. Second trace. I'm going to find my zeros first. My zeros are my x-intercepts. I'm asked for the left bound, so I'm going to move my cursor to the left side of this intercept and hit enter. Now it's asking for the right side of that point, so I'm going to move it to the right and hit enter. And hit enter again, and I can see that one of my zeros is at negative 1.50. That's one of my x-intercepts. Now I'm going to do the process again. Second trace, find the 0. I'm going to move over here. Anywhere right here, anywhere from here this way is going to be on the left side. So I'm on my left side already. I'm just going to go ahead and hit enter. Now it's asking me to move to the right side. So now here's the point I want. My cursor is now to the right of that. Hit enter. And I can see that I have another intercept at 2, 0. So my roots or my solutions are negative 1.5 and 2. Negative 1.50, 2, 0. Okay, so I'm going to go ahead and plot those on my graph. Negative 1.50 and then 2, 0. So now I have 2 of the critical points on this graph. Now I'm going to find the y-intercept. The y-intercept is going to be the point where the line crosses the y-axis. Let's see. Let's go to the minimum first, because we're going to find the y-intercept a different way. We're going to see if we, we'll just do it by tracing. So we're going to do the vertex right now. Left bound. I need to go to the left side. I know the vertex is down here, this lowest point. I'm on the left of it. I'm going to move to the right of it, hit enter. I'm going to hit enter when it says guess, and it tells me that it's at 0.25 and 6.125. Vertex, 0.25, negative 6.125. Okay, so there is my vertex. So 0.25 is going to be a fourth, and then negative 1, 2, 3, 4, 5, 6, and then 1.25. So here we go. There is my minimum, my vertex. Okay, that means this is my axis of symmetry. Half of my parabola is going to be on this side, half on this side. And then I noticed that I can just hit trace on my, when I'm on the graph, I'm just going to hit trace, not second trace. And I'm going to scroll over until x is 0. When x is 0, I'm at my y-intercept. So the y-intercept is at 0, negative 6. I should have done that with a different color, sorry. It's going to be here, 0, negative 6. So now I can sketch in my graph. So it's going to go something like, oops, I missed. A little skinnier, there we go. Something like this. I found the roots, the intercepts, the vertex, and now I can plot my graph. And that is all using your calculator, okay? As is this next section. Identify the minimum or maximum and the axis of symmetry of the following. Remember, we talked about our vertex gives us the axis of symmetry and the max or min. So we just have one step really to solve these two problems. So I'm going to go into my calculator, I'm going to go to y equals and clear out what's ever in there. X squared minus 4x plus 3. I'm going to go ahead and graph it. And there it is on the graph. And now I know that I'm looking for my min or max. I can see it opens upward, and I knew that because the leading coefficient was positive, but when I graphed it, I see the visual. That means it has a minimum, a lowest point. So now I'm going to trace the minimum. I'm going to go, I'm on the left side of it because I'm looking for this point down here, so I hit enter. Use my arrows, move my cursor over somewhere on the right side of it. And I see that my minimum is at 2, -1. Over 2, down 1. This is my vertex. Okay? It asks you to minimum and the axis of symmetry. Remember, the axis of symmetry can be found using this number here, but it is a line, so it needs to be written x equals 2. That is my axis of symmetry. Okay? Remember, it's a vertical line that it crosses through the x-axis. That's why the format of the equation is x. X equals 2. And my minimum, that means the lowest y value is at -1. Okay? So those are the two things it asks for. And you need to identify that it is a minimum. Okay? Let's look at the next one. Y equals... remember that f of x is the same thing as y. If that's throwing you off, feel free to just write it as y. This is just function notation, but f of x and y are interchangeable. Okay? Don't let that mess you up. Y equals negative, and I see that -2 is the leading coefficient. So what do I know about this graph? I know that it's going to open downward. -2x squared minus 6x minus 4. Can see that it's opening downward. I'm looking for the minimum or maximum and the axis of symmetry. I can see on this one it's going to be a maximum. So when I do calc, I'm going to go to number 4 this time, maximum. I need to be on the left of it. Here's the point I'm looking for. I can see my cursor's over here. That's the right side of the point I'm looking for. I need to be on the left side. So I move my cursor to the left. Now it wants the right side. And move it back to the right. Oops. Oh no. I pushed it one too many times. Left, right, and there it is. We have -1.5 and 0.5. This is my vertex. This is my axis of symmetry. So x equals -1.5, the equation of that line. And my maximum is at 1/2, 0.5. Okay? We'll continue to use our calculators here. We're going to find the zeros of the equations. All right, so I'm using my calculator. I'm going to go in, clear that out. 3x squared minus 13x minus 10. Graph it, and I can see this parabola. I'm not able to see the minimum on this one. Fortunately, all I want here is the zeros. But if that is the case, remember you can adjust your window using window. You can mess with these if you want, or and then if once you mess with those, if you put zoom 6, it'll take it back to your normal window for you. So if you change the window, you can zoom in and out, or you can change it using window. If you do that and you need it back to your normal, zoom 6. Okay? Okay, but here I'm looking for zeros. So I'm going to do second trace, 0. I'm going to find the one over here first. So left side, right side, enter, and I can see the 0 is at negative, I'll do 2/3 because I don't like that big long decimal. And then same process, second trace, 0. Now I'm going to this one over here, this x-intercept. There we go. Enter on the left side, enter on the right side, and I can see the other 0 is the 0.50. So strictly using our calculators, we can find all of these solutions. 24x squared minus 36x equals 24. How do I put that into the calculator? I can't move this to this side of the equal sign. And we know from solving so many equations that in order to move across the sign, across the equal sign, we have to do the inverse operation. So we would actually subtract 24 from both sides. So that's going to give us a 24x squared minus 36x minus 24. And that is how I will have to type that in. So when I graph it, again, I don't see my minimum, but I do see my zeros. So that's what I'm looking for in this problem. Whoa, okay, I'm on the left side, and now I'm on the right side. And I can see there's 1 0 at -1/2. And I'm going to do the same process. Second, trace. Number 2 is 0. I'm going to make sure I'm on the left side. Hit enter. Now I'm going to do the right bound. Hit enter. And I can see the second 0 is at 2, 0. Okay? So lots of calculator use here. Lots of calculator use. One final thing, and this is really just a reminder from all of the stuff we've already done, but you could be asked to find the domain and range of graphs. And parabolas are a part of that. So if we're looking for the domain, this is a continuous function, meaning we'll be using the notation with the inequality signs. I start at the left. I see this arrow, meaning this goes on towards the left and down forever. So that's going to be basically from -infinity. And same thing on the other side. So it's going to go all the way to +infinity, my x's. So that means my domain is all real numbers. Okay? Domain is all real numbers. My range is going from bottom to top. Start at the bottom. I can see this goes all the way down to -infinity. I go up, up, up. Oh, here's the end of the graph. There is no more graph above 2. So 2 is the highest that this could go. And it is touching 2, so it would be equal to. We discussed the fact that we don't really need to say -infinity all the way up. We can just say y is all the stuff less than or equal to 2. So my domain would be all real numbers, and my range would be y is less than or equal to 2. These are the places where you can find this graph. Let's do this one. Domain, I start at the bottom, I move up, 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 up. First time I see any information is at -2. Keep going, it goes all the way to infinity. So -2 is less than or equal to x is less than infinity. Again, this is repetitive. And when we write it, we want to have the variable first. So my domain is going to be x. And now when I want to write this first, I need to make sure that my sign is still eating the x and that the -2 is still the little guy. So I have to flip that over if I'm going to rewrite it like that. There's my domain. My range, I just did that backwards. I'm sorry, I found the range first. That is my range because I went bottom to top. Trying to go too quick here. My domain is left to right. Again, I have these arrows going on forever. So this will be all real numbers.